All right, we're jumping down to the next section. I'm only probably going to do one problem over here, 21. So let's just get down to it. You're pretty much doing the same methods. There is a 1 over here. And so we're just going to figure out what two numbers multiply to 16, but add up to -8. If you said 4 and 4, maybe that's not the case because this adds up to +8. But -4 and -4 will have, when you add them up, makes a -8, and multiply them will make a +16. Okay, so this is your middle step, actually, x minus 4 times x minus 4. But if you have two of the same factors, so these are called factors, the ones in the parentheses, then you're going to rewrite them as x minus 4 quantity squared, like this. So this is how you're going to write all of your answers from 21 on to 28. And 29 is also a little bit similar. You might have to take a greatest common factor first. Okay, so that's how you're going to do this section on page 3. Let's go move on to a couple ones over here. This is called differences of squares. The reason why it's called differences of squares is you're literally subtracting two squares together. The reason why it's a square is because squares have the same side, same lengths of sides. So if this is a 6, this is a 6, or if this is an 8, this is also an 8. So you're literally subtracting two different squares. Okay. If this is a b, then this is a b. Anyway, b times b is b squared. Here is one way you could think of this. I taught it in Algebra 2. One way you could think of this is if you don't see a middle term, because usually we have like a middle term over here with just the variable and the number, the coefficient. If you don't see it, you can add a 0b minus 64, and then that would be okay. And then you can think of yourself, well, what two numbers multiply to -64 but add up to 0? And it's going to be your opposite number is 8 times -8. Okay, so you could do that. Then it's going to be b plus 8, b minus 8. So that is one way to do it. The reason why, again, it's called differences of squares is if you can see that these are squares, like b times b, and this is 8 times 8, and there is a minus sign, you can factor it like this. You cannot do it with the plus. It needs to have, must have a minus. Must have. Okay. If there's a plus sign and there's squares over here, there's no sum of squares. That's unfactorable. You cannot do that. So this is how you're going to do numbers 35 all the way to, I believe, 48. Let's tackle a couple of the numbers, maybe just one more number like 45. Okay. So again, one way you could do this is, I'm just going to use this rule of the differences of squares. Okay, so b squared minus 64. We could square root them, and then it will be b and b. 8 times 8 is going to be 64. Let's try to do it this way. Suppose that we can square root both of them like this. Well, let's take the positive square root. This square root of 4 is 2. Square root of m squared is just going to be m. Okay. To factor this, we need 1 as a plus and 1 as a minus, just like how we've done it over here. And then now let's go square root the 9n squared. Square root of 9 is 3. Square root of n squared is n. And this is your factored form. Again, if you need to check your work, if you're not too sure that this rule applies, go ahead and do your FOIL. You know, 2m times 2m is 4m squared. This is going to be -6mn. The inners is going to be +6mn. So when you do the O and the I, the outer and the inner, when you add them up, they're going to zero out. And then 3 times -3 is -9. N times n is n squared. So this rule will work all the way up to number 48. Okay, and then for 49 and 50, you might have to take out a GCF first. Okay. Let's do something like 51 where the A is not a 1. And if you were in my Algebra 2 class, again, there are so many different ways to do this, but I would like to teach it this way. That way we're not drawing too many boxes or too many shapes like this. we're going to break down. If your A value is not a 1, I want you guys to do it this way. First of all, let's check to see if there's a GCF. Is there a GCF over here? No, I don't think we can take out a 2 on all of them because the 5 is not divisible by 2. We can't even take out a variable because this doesn't have a variable. So there's no GCF for number 51. If there's no GCF and the A value is still not a 1, this is one way to do this. We're going to split up 2k squared into 2k times k. Okay. So you're going to split up the first term and then you're going to split up the last term. One of the ways to the factors for positive 2 is 2 times 1. Okay. All right, you are going to pick and choose which ones you're going to multiply to which so that they add up to a 5k. So this is what I mean. I'm going to select, so this is trial and error. I'm going to match up the 2k with the 2 and then add it up. Then I'm going to match up the k with the 1. And I believe that should add up to 5k because 2 times 2, 2k times 2 is 4k. K times 1 is 1k. And then that's going to be 5k. All right, so that's what we want. This is not the final answer yet. Once you have the correct pairing, this is what's going to happen. The first pair that works, the 2k and the 2, you need to put them on the outside. Put them on the outside. So the answer of 2k plus 2, that is not correct. Okay, you need to put them on the outside. The second pair that works goes on the inside, but you just got to make sure that the second variable goes on the second parentheses over here. And this number, it's positive, so it'll be plus 1. So this is how you're going to factor something, a trinomial where this is not a 1. And we try taking out a GCF, and then there's nothing. Okay? So break out the first term, break out the last term. You're going to do trial and error to see which ones, multiply together and add up to make the middle term. Make sure the first pair goes on the outside. If you want to check your work, you can do FOIL or box method to do that. I want to do one more example on this. Let's pick this one. Let's try 55 so that you guys can see another method. Okay. All right, let's take a look if there's a GCF that we can take out. 7, no, we can't even take out a 7 on any of them. There's 2 x's here, there's 1 x, and there's no x. So, there's no GCF over here. All right, the only way to split up 7x squared is 7x and x. We're going to deal with the negative 25 a little bit later. Be careful, we have a negative. So that means that for your factors in the last term, you need to have one that's positive and one that's negative. So 4 and negative 3. There's also a possibility of negative 4 and positive 3. And I'm going to write down one more, 6 and negative 2, negative 6 and 2. You know, there's a lot. You can sometimes 1 times 12 also works as well. But this is now trial and error. We got to figure out which ones we should pair up with so that it adds up to negative 25. I'm just kind of do this slowly in my head. And I'm already going to eliminate 7 times 6 because 7 times 6 is 42. It's a little bit too much. And don't forget, you can also go the other way as well. 7 times negative 2 is negative 14. Plus 6 is going to be negative 8. I think that's a little bit too little. Okay, so I think the correct answer is we're going to pair up the 7x with the negative 4. And then again, also try some other combinations as well because they could work. But once you pick this pair, you have to pick the pairs that are associated with that. You cannot jump, this x cannot jump in with the negative 2 because that's not the same pairing. That's not the same pair that's together. Okay, so the x and the 3, let's just try this one out. 7x times negative 4 plus x times positive 3. Let's see if that makes a negative 25. 7x times negative 24 is negative 28x plus 3x. Yeah, this is the negative 25x that we are wanting. So just be careful on how you're going to lay out the final answer. Okay. 2 parentheses like this. Where does the first pair that works? Where do they go? Make sure they go on the outside, 7x minus 4. And then the second pair that works goes on the inside. Okay, again, if you want to check your work, you guys can use FOIL or box method for that. See you on the next video.